Okay, so Samia, you can start the presentation.
Okay. Hello. So we are the fractal generators, and our team is Samia, so myself, April, Jen, Johanna, Zakir, and Zengtao, and of course our instructor Noah. And our project is predicting supermarket sales. So our goal with this project is to be able to predict the sales of a supermarket given a few of its features. So about our outline and our data. So we got our data from Kaggle and uploaded it to CoCalc. And then using Python, we worked together to create different models and find the best way to basically represent that data that we got. And in these models, we use information about some factors in a supermarket to predict store sales in order to help retail businesses become more successful. So moving on to our EDA. As I mentioned, our goal is to be able to predict the sales of a supermarket using a few of its features. The 5 different columns of data in the supermarket data set were store ID, which was used to identify just an individual supermarket, store area, items available, daily customer count, and then store sales. Using these features or independent variables, we're able to predict the dependent variable, which in this case would be sales. Each column had 896 rows, and thankfully there were no null values, so that we didn't have to take care of that. Okay, this table here shows the different statistics for the 5 columns which were given. So store ID, store area, items available, daily customer count, and then sales. But we also added another column of data on because we felt that we needed more factors and more data in to get a better prediction. And so that is also shown in this table. And using those columns, we're able to predict sales. So now I'll pass it to Zengtao to talk about the features themselves.
So this is a scatter matrix, which is a bunch of scatter plots between the different columns in our data table put together into a grid. So you can see the different relationships between the columns. And next is an individual scatter plot for area on the x-axis and customer count on the y-axis. And the different colors represent the different incomes of the stores in US dollars. And as you can see, everything's pretty spread out. And this is a scatter plot. Yeah, so area and items available. And areas on the x-axis and items available is on the y-axis. And you can see there's a strong linear relationship. And you can see the different incomes of the different stores. And as Samia said earlier, we didn't have that much data. So we added a categorical variable called store scale, and that just tells us if the store is small, medium, or large based on its area. So the blue color is a medium store, the orange color is a small store, and the green color is a large store. And the pie chart just shows the percentage of the customers who went to a small, medium, or large store, and the pie chart on the right shows the percentage of sales that came from a small, medium, or large store. And this is the box plot, which should show the mean, the 25th and 75th percentiles, the highest and lowest values, and any outliers. And the box plot is for area, items, and customer count. And to show the distribution, we made a histogram for items, area, and store customers. And finally, we have a heat map. So this shows the correlation between the different columns. And we're trying to predict the store sales. And as you can see, the different columns that relate to the store sales are close to 0 in correlation. So there doesn't really seem to be a relationship between the columns and the store sales. So Johanna's gonna go over the next section.
Right now we have the feature engineering. Here on the plot charts, it shows possible correlations. We have found that there are no correlations to the store sales and the other factors in the supermarket. In terms of collinearity, which is the correlation between the independent variables shown in the heat map. The only clear collinearity is positive, which is between the area of the store and the available items. However, there's also collinearity between the total customers divided by the store area and the area of the store. When looking for outliers, we use the local outlier factor method in Python, and we changed the data table to include only non-outliers. In terms of missing values, we were lucky to not have any, but if we were to encounter that issue, we would have deleted sections with the missing values and simply replaced them with median or mean values.
I'm going to talk about modeling. Our machine learning model is used to predict regression in how much a supermarket will earn from sales daily. We measured the accuracy of the predictions through the mean absolute error. A lower MAE should indicate a better prediction, but we noticed that it might not necessarily be good for machine learning. Lower MAEs usually resulted in the predicted data being centered and less spread out, so that stores that were higher and lower income weren't represented. For linear regression analysis is a way of sorting out which variables have an impact on an analysis of data. There's a clear correlation between the effects of the independent variable on the dependent variable, whose overall trend is linear. Random tree regression works well with nonlinear data and has better accuracy than classification algorithms, but it's found to be biased when dealing with categorical values, and it's very slow to train. Some of the pros of gradient boosting are that it decreases bias error, it can be utilized for regression and classification problems, and the training speed is much faster and more efficient. However, it's computationally expensive, and its algorithm constantly improving errors could lead to overemphasized outliers and cause overfitting.
So for XG boosting, it can be used for classification and regression. It's similar to random forest regression because of the use of trees, and the combined outputs, are combined in XG boosting. For neural network, it's very accurate in determining the patterns that exist within linear and nonlinear patterns within datasets, which makes them more powerful than other regression models like linear regression that fail for nonlinear datasets. For polynomial regression, it provides an accurate approximation between the dependent and independent variables. However, it's sensitive to outliers and can change data drastically. For decision tree regression, this model can be used for both classification and regression problems, and it's easy to visualize, interpret, and understand. However, overfitting happens when the learning algorithm continues developing hypothesis that reduces the training set error, but at the cost of increasing test set error. Lastly, for elastic net regression, it performs variable selection and regularization simultaneously, and it's most appropriate where the dimensional data is greater than the number of samples used.
Zakir, are you here? So, okay, so I think one of my teammates just not showing up today, so I'll talk about the evaluation part. So we are currently trying different model in the model section, and among all the results, we will find out that we got the best result from polynomial regressions. So this is the table for the MAE for different models. So you can see our goal MAE is about 13,228. So this is because we get this data set from the Kaggle competition, and this is the first prize who the rank one who achieved this number. So this is our goal to overcome. And based on our student effort, they just reached the lower MAE about 13,855, which is really great. It's close to the rank one. So I appreciate their work on doing the modeling and point out some opinion on choosing the feature. So according to the feature engineering part, I asked everyone to do the research about how to select the feature. And because just like what you say, in the given data set, there are only 3 features. So I asked them to think about which kind of feature they can think about. So we just come up with the store sales and create a categorical variables, and somehow that variable do work on our prediction. So our optimal model is the polynomial regressions, and this is the MAE. So when it comes to the summary, so my conclusion is that because our supermarket analyzed model predict the source sale by the variety factor, or such as item available or area of store, and whatever the model, whatever the feature they give us, and we do want to find out the best way to create a more store sales to attract the customer and increasing the sales. So we do in this project, we do predict a lot of things like pandas, numpy, and instead of using the matplotlib, I encourage everyone to use the plotly because everyone knows that plotly can create a interactive plot for everyone, and so you can introduce the plot to like everyone here. We can have the interactive between the plots. So I appreciate everyone have already learned a lot of things about the plotly. And one thing we want to improvement is that we have only was 3 weeks, so we didn't have too much background research on the data set. So if we have time, we would like to create more, have more time to do the background research and recommend the supermarket data set can also how much time the store are operating for daily. So we can get this kind of feature, which is more important to predict the store sales. And also we noticed that our MAE is not as lower because maybe this data set is designed to wouldn't get a bad performance. So we go to the future plan. So in future, we wanted to use a more larger data set because in current study, we only have about 896 pieces of data, and this is too small for like the sales store predicting. So we in the future, we want to get more data about the supermarket sales. And one thing is that, so our feature there is like, doesn't have the type of store. So example, I want to, maybe we can create a more feature like the type of store like the grocery or like the jewelry store. And this kind of type of store might become different with the store sales. And so this is our future plan for the supermarket project. So then let's go to the next section. So this is the team member of our team. And thank you everyone for your listening.